Good morning, everybody. Sorry, I'm out again today. I have to take my son to get a COVID test. So, unfortunately, we do have to do notes this way again, but hopefully everything worked out good last time, so this should be just as good. So, today we are doing section 7.4. This is properties of special parallelograms. So, this is where I said that we were getting into the different type of parallelograms, so rhombuses, rectangles, squares. So we do have quite a few definitions to kind of pay attention to here. So we have a rhombus, which is a parallelogram with 4 congruent sides. Remember, parallelogram just means opposite sides are parallel. A rectangle is a parallelogram with 4 right angles. And a square is a parallelogram with 4 congruent sides and 4 right angles. So if you have a shape and it tells you all the sides are congruent and all of your angles are right angles, then it is automatically a square. Whereas if we have a shape and it just tells us these 4 angles are right angles, then we have a rhombus, then we have a rectangle. So you just kind of have to pay attention to all of the little details to determine what type of shape we have. And then that's kind of what these next 3 definitions get into a little bit. It's the rhombus corollary, rectangle corollary, and square corollary. So rhombus says a quadrilateral is a rhombus if and only if it has 4 congruent sides. Rectangle says a quadrilateral is a rectangle if and only if it has 4 right angles. And square says a quadrilateral is a square if and only if it is a rhombus and a rectangle, or also stating if and only if it has 4 congruent sides and 4 right angles. But instead of writing out all of that, they just said it has to be a rhombus and a rectangle for it to be considered a square. So I'm going to keep on moving through, but remember, you guys can always pause this video if you need to copy down any definitions or kind of see what I wrote and see how it makes sense and all of that stuff. So for these first 2 examples, again, kind of proof-based a little bit, just using what we know about the shapes and seeing kind of how they work. So it says, for any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. So let's see. Let's start here. Let's make a shape. It's not going to be the prettiest shape, but we will make a shape. Okay, so this is QRST. And they are saying that Q is is congruent to S. So we have to decide if that statement is always true or sometimes true when it comes to rhombuses. Well, we know that a rhombus is a parallelogram. Let's see. Okay, so since it is a parallelogram, that means that opposite sides are congruent. So then, by your opposite angles theorem, opposite angles are congruent. So therefore, this always has to be true. So a rhombus is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. And then we also learned that If both pairs of opposite sides of a quadrilateral are congruent, then a quadrilateral is a parallelogram. And so with all of the different theorems, we know that those opposite sides have to be congruent. And then because of that, we can use our opposite angles theorem to know that opposite angles are always congruent. So in this case, angle Q being congruent to angle S would always be a true statement. So then B, again, we draw some shape. These do not have to be proportioned at all. It's really just a matter of kind of how you label it. And so for this one, it's angle Q is congruent to angle R. So the only way that angle Q could be congruent to angle R would be if we had right angles. So if the rhombus is a square, then all four angles are right angles. So angle Q would be congruent to angle R. However, this isn't always the case, right? Not every single rhombus is going to have four right angles. So this is only sometimes true. So a rhombus can be a square if we have four right angles. But if that's not the case, then for sure the opposite angles are congruent, so in like part A, say angle Q was 40, then angle S would also be 40. And then remember our consecutive angles, so if they share a side, they add to 180. So R and T would be 140 in that regard. All right, number 2 says for any square JKLM, is it always or sometimes true that JK is perpendicular to KL? Explain your reasoning. So again, you can draw a picture, but it is not super necessary. So we have a square. Whoopsies. So we have a square, J, K, L, M, and then it is asking about JK and KL, and asking if it is always or sometimes true that those two lines are perpendicular. So this is always going to be true, because remember, a square has four right angles, four 90-degree angles. So therefore, those two lines, they're going to form a right angle because this is a square. So by definition, a square has four right angles. And then for number 3, it says for any rectangle EFGH, is it always or sometimes true that FG is congruent to GH? Explain your reasoning. So some of these you can just kind of imagine too. You guys know what a square looks like, what a rectangle looks like. Rhombus is probably the only one that's kind of new. And so it is asking, is it always or sometimes true that FG is congruent to GH? Well, in a rectangle, we know that we have two short sides and two long sides, right? So in this case, a rectangle doesn't normally have the same measurement for the side and the bottom, right? However, in this weird case, remember that a square is a rectangle, or a rectangle is a square. They kind of are interchangeable that way. So this would sometimes be true because some rectangles are squares. And so this is where, like I said, it gets a little confusing. It just goes back to those main definitions. So a rhombus has 4 congruent sides. A rectangle has 4 right angles. And then a square has both of those things. So if you were given a shape that said you have 4 right angles and 4 congruent sides, technically that shape is a rhombus because it has 4 congruent sides. It is a rectangle because it has 4 right angles, and it is a square because it has both. So this is where it gets a little tricky on kind of deciphering what's the name of this shape. But it's because all 3 of those work, and then you just have to pick the one that best fits it. So in this case, a rectangle, we know for a fact, has to have 4 right angles. But we also know that squares have to have 4 right angles. And so if the shape also satisfied the things to be a square, our shape could be a square as well. So this shape could have all sides congruent because it could be a square. And so this is where it kind of gets to classifying, like I was just talking about. So it says classify the special quadrilateral and explain your reasoning. So based off of the information they give us, we have to decide, is this a rhombus, a square, or a rectangle? So the information they tell us, all 4 sides are congruent. So looking back at those 3 definitions of a rhombus, a rectangle, and a square, which one has 4 congruent sides? Well, a rhombus has 4 congruent sides, and a square has 4 congruent sides. The difference is a square also needs to have 4 right angles. This angle right here is not 90 degrees. So for that reason, we can't have 4 right angles. So the only thing that we do have working for us is we have 4 congruent sides. And the only shape that works with that one is a rhombus. So it's a rhombus because we have 4 congruent sides. And then since one angle is 70 degrees, we can't have 4 right angles. In the next one, it says a quadrilateral has 4 congruent sides and 4 congruent angles. Sketch the quadrilateral and classify it. So if we have 4 right angles and 4 congruent sides, the best option for classifying that is going to be a square. It says it directly in the definition. For it to be a square, it has to have 4 right angles and 4 congruent sides. That's exactly what this one says. So it is a square. So then the next thing we get into is the rhombus diagonals theorem and the rhombus opposite angles theorem. So for the diagonals, it says a parallelogram is a rhombus if and only if its diagonals are perpendicular. Remember, if the diagonals are perpendicular, it means that they form 90-degree angles in that center where the diagonals cross. And for the opposite angles, it says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. There's that word bisects again. It comes up often, right? Remember that bisect means that it cuts something in half evenly. And then it bisects the opposite angles. So that diagonal, when it goes across, the angles that it is crossing, it cuts those in half. All right, so let's put some of that information to use. So for number 1, it says find the measures of the numbered angles in rhombus ABCD. So this is a rhombus. So we use the information we just learned from those 2 theorems to solve for these missing angles. So angle 1 is easy because they said that our diagonals have to be perpendicular. So that means all of these angles in the middle here are right angles. Every single one of those are right angles. So angle 1 has to be 90 degrees. So now finding angles 2, 3, and 4 is a little different. We also know that opposite angles in a rhombus are congruent because remember in a parallelogram, opposite angles are congruent. A rhombus is a parallelogram. So this whole angle here is going to be the same as this whole angle here, right? So that means that this little piece is going to be the same measure as this piece. And then we also know that in a rhombus, diagonals bisect our angles. So that means that since this angle is 61, this one is also 61. So that means angle 2 is 61 and angle 3 is 61. So then that just leaves angle 4. So angle 4, if we look at this, notice that we have a triangle. And we know that in a triangle, all 3 angles add to be 180. And we now know that angle 1 is 90 and angle 3 is 61. So if we do 180 minus 90 minus 61, we will get 29 for angle 4. All right, and our last one. Again, remember I'm kind of speeding through this, but you guys can always pause, rewind, go back, double check, and see how I did stuff. So last one again, it says find the measure of the numbered angles in the rhombus. If you guys want to pause for a second and try this one on your own before I work through it, that wouldn't be a bad idea. So again, remember that these diagonals bisect. It would not be a bad idea to draw your other diagonal so that it looks a little more similar. And then notice that this angle here was 118 for all of G, but now that we've formed that diagonal, we actually cut that in half, right?
If you'd like to join us for prayer, we're together inside Learning Camp.
So we would do 118 divided by 2, and that would give us 59. So when this diagonal bisected that angle, it made these two little pieces here 59. And then again, remember that we know that all of these angles here are 90 degrees because those diagonals are perpendicular. So then in order to find really the measure of any of these angles, we have our triangle. So we do 180 minus 90 minus 59, which gives us 31. So that tells us this angle is 31. Remember, those diagonals, they bisect our angles. So that means 4 is also 31. And then also remember that opposite angles are congruent. So that also tells us that 2 is 31 and 1 is 31. So every single one of these angles has a measure of 31 degrees. All right, and those are the notes for today. You guys do have a worksheet to do. You also had the worksheet at the beginning of class. Both of those are due next class. I am hoping to be here tomorrow, kind of dependent on how my son's test turns out today. If you have any questions, make sure and come see me during Empower Hour tomorrow. I'm happy to help. Email me with any questions. I know this is really kind of crummy for you guys that I've had to teach you 2 lessons through a video, but hopefully it's still at least getting the information out to you. And then if you have any questions, like I said, just definitely email me and I will do my best to respond.